Example 7. Okay. This example illustrates the super good use of GC. Super good. Really, really. This one save you a lot of trouble. The difference is now the question give you 1, 2, 0, 1, -2, 0, 3. These are how many data points? 8 data points. N equals to 8. Correct? N equals to 8. And these are individual data. Okay, Can you have attention, please? Thank you. Assume that these losses, this is the loss of what? Weight loss. Weight loss. Okay, weight loss. 1, 2. Significant, meh? At the end of what? How long? Then say what? How long? Lousy problem. FMAX 1978. 37 years old. Was I born? This one year end or June? Not born yet. Okay. Assuming the losses are random sample from a normal distribution, that means X is normally distributed. Okay, you want to test whether the losses are significant enough. All right, significant enough at a 5% level of significance. So step 1, we define the random variable. Step 2, state your hypothesis. You want to find out whether the losses are significant enough, you will do only a one-tail test. Yes, because you want to lose weight, right? Correct? You want to check whether mu is greater than 0 or equal to 0. So it is a one-tail test. Level of significance 5% given in the question. Test statistic. If H0 is true, X follows. And since X, this one is from the question. From the question says that X is normally distributed. Therefore, your statistic, is it a Z test or a T test? T test because N is small, sigma square unknown. So it is a T equals to X bar minus 0 divided by S. Notice I use this as a big uppercase, all right, because these two are variables. Divide by root 8 because N is 8. Degrees of freedom is N minus 1. Now, this is all from GC. So now I'm going to demonstrate how powerful it is to use the GC. Okay, look up. Look at the problem again. Sigma square unknown. You have to find unbiased estimate. If you notice, in the rest of the printed part, nowhere did I indicate how to calculate S, the calculation of S. Correct? How do you calculate S? You calculate S from here, right? From your individual data, right? Correct? Yes? So now I'm going to show you, actually the GC is going to do the hard work. If you enter individual data inside, the GC is going to conduct the test for you at the same time using the S that they calculate from the individual data. One more time. What I mean is, if you want to use your GC, you're going to use unbiased estimate from here, right? You can calculate that. But the GC can help you do it. How? You are going to do this. Stat edit. You are going to enter all the data 1, 2 as a list. Stat edit 0, 1, -2, 0, 3, 3. 8 data points, and then stat calculate, or rather test, you have to decide from the start that it's a t-test. Now this time, instead of choosing the statistic mode, you enter the data because you actually have individual data. Follow? So data. Now you want to test whether mu is 0, that means the weight loss is 0 or greater than 0. This time, your list, you are telling the GC that my data is in the list, and each data has frequency 1. And you do a one-tail test, and the GC will help you do everything here, including the calculation of unbiased estimate. Damn good. Right? Damn good, right? Going to do work, right? For what I'm saying. So look at the p-value here, 0.69. That's how the 0.69 is okay. All right? Are you okay? Are you okay? Can? You decide beforehand there's a t-test, then the rest is quite easy. Computation is a test statistic. Sorry. Test statistic, computation. Then you get p-value. This one again not necessary. You all know the drill, not quite necessary, okay? But it's good for understanding. Since p-value is greater than, that means it's not so rare after all. Correct? Since the p-value is not so small after all, then the area not quite big, therefore H0 is not rejected. I think by now you also realize the language used. We will always say H0 rejected or H0 not rejected. We will never say H0 accepted. We will never say H0 accepted. Because from the way we test, we can say that whenever we say H0 rejected, that means we are saying that this probability is very small, correct? Very small. If we say it's rejected, it's very small compared to 5%. Therefore, we say H0 rejected because there's only a 5% chance of failure, correct? So we say H0 rejected. But when it is not rejected, when it's greater than 0.05, we will never say it's accepted. Never say it's accepted. Because you only know when you reject, you can say with a 5% error. But when you accept, you don't know what is an error, so we never say it is accepted. Follow? So we always say not rejected. At a 5% level of significance, so the losses are not significant to support the manufacturer's claim. We are moving on to miscellaneous examples.